My project is homemade hydrometer. Hydrometer is an instrument which is used to calculate the density of various liquids. Hydrometer works on the principle of buoyancy, which is known as the principle of Archimedes. Now we will discuss about the various parts of hydrometer. Hydrometer has three different parts: the weighted bulb, the narrow stem. So now we'll start the process by first making the bulb of a hydrometer. The syringe is going to be the bulb of a hydrometer. We have to first block this small tip with hot glue and place our weight inside the syringe. Now we will start making the narrow stem of our hydrometer. You have to first take a bottle cap and make a hole appropriate to your ice cream stick and place it inside. Now our bulb and narrow stem are ready. Now we will attach the narrow stem to the bulb in the main opening of the syringe. Now our main part of hydrometer is ready. Now we have to stick the scale to the hydrometer. The zero should be placed near the bulb. Now we will see how hydrometer works. Hydrometer works on the principle of buoyancy. The principle of buoyancy states that when an object is immersed in a liquid, the upward force acting on an object is equal to the amount of liquid displaced by the object. So when hydrometer is placed in a dense liquid, it needs to displace only a little bit of liquid to balance its weight and stay afloat. But whereas in a liquid with low density, a hydrometer has to displace a lot of liquid so that the upward force will balance the force of the hydrometer and it will stay floating. Hence, in a dense liquid, a hydrometer doesn't need to sink as much. But in a liquid with less density, a hydrometer needs to sink deep to displace more liquid. Now, our hydrometer is ready. Now we'll see how to use our hydrometer. First, we have to gently place hydrometer in our liquid and read the level in which our liquid is in the scale. Other hydrometers have complex units, but here we are going to use centimeter scale for simplicity. Now we are going to do experiment in water and water with salt. Water is less dense, but water with salt is more dense. So first, here we have water, plain water without any salt. Now we can say it is reading 3 centimeter. And since it is less dense liquid, hydrometer has to sink a lot. Previously, we did experiment with plain water, which was less dense liquid. Hence, our hydrometer had to sink a lot. Now, we will do experiment with more dense water. To increase the density of water, we will add salt to it. We are going to add more salt to make it more dense. Now, we will use our hydrometer in more dense liquid, which is water which is saturated with salt. Now, we can see with our experiment that in more dense liquid, our hydrometer didn't sink as much as before. This is because the buoyancy in more dense liquid is more, so it is easily able to balance itself in more dense liquid. Hence, by our experiment in more dense liquid, we got 2 centimeter. In conclusion, from our 2 experiments, we found out that our hydrometer sank 3 centimeter in less dense liquid and 2 centimeter in more dense liquid. This clearly shows the principle of buoyancy by Archimedes. These experiments and our model hydrometer helped us to learn about the principle of buoyancy and illustrated how real-world hydrometers work. Thank you.